Forget what you heard, because the story of 3IATLAS is getting weirder by the day. This isn't just another comet. New images and fresh calculations are pointing to something truly bizarre, something that standard astronomy can't easily explain. We're talking about anomalies so strange that they force us to question everything we thought we knew about interstellar visitors. This all started when a team, including renowned astrophysicist Avi Loeb, took a closer look. What they found is a puzzle wrapped in an enigma. First, there's the tail. Or should I say tails? 3IATLAS sported two distinct laser-straight tails pointing away from the sun. Now comets have tails. Sure. A dust tail that curves along its orbit, and an ion tail that points directly away from the sun. But ATLAS's tails were both straight, like twin searchlights cutting through space. That's anomaly number one, and it's a big one. It just doesn't fit the classic comet model. It suggests the material was ejected at an extremely high velocity, far faster than typical sublimation would allow. So what force could do that? Then there's the mass loss. As 3IATLAS got closer to the sun, it started to disintegrate, which is normal for a comet. But the amount of mass it shed was, for lack of a better word, impossible. Based on its size and how much material it was losing, it should have completely vanished. We're talking about a catastrophic level of disintegration. Yet, it didn't. The nucleus, the solid core of the object, somehow survived this impossibly rapid diet. How can something lose so much of itself and still hold together? It's like watching a building crumble to dust, but finding the foundation perfectly intact. This is anomaly number 2, and it directly contradicts our understanding of cometary physics. The numbers just don't add up. And that brings us to the third and perhaps most baffling mystery, its brightness. As 3IATLAS began to break apart, it should have faded away. Less material means less sunlight to reflect, right? Wrong. In defiance of all logic, the object's brightness held steady. It refused to dim. Even as it was supposedly losing enormous chunks of itself, its light signature remained stubbornly consistent. This is a massive headache for the "it's just a comet" explanation. If the main body was disintegrating, where was all this reflected light coming from? Was there another source of brightness? Was the main fragment much larger and more reflected than we calculated? Either way, our models are broken. These three anomalies, the twin straight tails, the impossible mass loss, and the unfading brightness paint a picture of an object that is anything but ordinary. Avi Loeb and his team ran the numbers, and the standard comet explanation fails on all three counts. The data tells us a different story. It points to an object with properties we've never seen before. Now, Loeb is famous for his work on Oumuamua, the first interstellar object we detected, and for suggesting it could be an extraterrestrial artifact. He's not afraid to challenge the consensus, and the data from 3IATLAS seems to be giving him even more ammunition. Let's be clear, this isn't about jumping to conclusions. It's about following the data where it leads. When our existing models fail to explain what we are clearly observing, it's time for new ideas. So what could it be? The paper explores a few possibilities. Could it be a fragment of a larger parent body that had unusual properties? Perhaps an object made of something other than the typical water, ice, and rock we expect from comets, like solid hydrogen or nitrogen ice, which would sublimate much more violently. Or, and this is where things get really interesting, could its behavior be explained by something non-natural? Think about the unfading brightness. A conventional comet gets its brightness from a cloud of dust and gas called a coma, which reflects sunlight. As the comet breaks up, the coma dissipates, and it gets dimmer. But what if the object's brightness wasn't just from a coma? What if the core object itself was highly reflective, or had a structure that maintained its reflective surface area even as it shed mass? It's as if the material was propelled outwards with some additional force. This is where the mainstream narrative gets uncomfortable. Because when you have impossibly fast ejections, impossible mass loss survival, and impossible brightness, you have to start thinking outside the box. The official line for many in the astronomy community is to stick with the knowns. They'll say we just need to refine our comet models. Maybe there are exotic types of comets we haven't encountered before, and 3IATLAS is just the first of its kind we've seen up close. That's a fair point. Science should be cautious, but it should also be brave. When multiple independent lines of evidence all point to a single conclusion, that this object is not behaving like a comet, we have a responsibility to investigate that, not dismiss it. This is the core of the 3IATLAS problem. It's a real space mystery, backed by hard numbers and clear observations that are available for anyone to scrutinize. We have the images from telescopes like Hubble. We have the calculations. And they tell a consistent story. Something is wrong with the just a comet theory. It's a classic case of an anomaly, a piece of data that doesn't fit the established paradigm. And throughout history, it's these anomalies that have led to the biggest breakthroughs in science. So, what happens now? The truth is, 3IATLAS is gone. It has swung past the sun and is heading back out into interstellar space, likely never to return. We can't get more data from it. All we have are the observations we made during its brief, chaotic visit. But these observations are a treasure trove. They are a challenge to astrophysicists to build better models, to think more creatively, and to be open to the possibility that the universe is far stranger and more wonderful than we imagine. Is 3IATLAS an alien probe? Avi Loeb himself doesn't claim it is. He says it's a possibility that shouldn't be ruled out, especially when natural explanations fall short. His argument is for a more open-minded approach to the search for extraterrestrial intelligence, one that looks for technological signatures, or technosignatures, not just biological ones. An object behaving this strangely is exactly the kind of thing we should be paying attention to. For now, 3IATLAS remains a profound puzzle. A ghost from another star system that swept through our backyard, put on a spectacular and baffling show, and then vanished into the dark. It left us with more questions than answers, and a set of data that stubbornly refuses to fit into our neat little boxes. It's a reminder that there's still so much we don't know about the cosmos. And it's the mysteries like these that keep us looking up, wondering what else is out there. If you found this deep dive fascinating, make sure to subscribe, and hit that notification bell so you don't miss our next exploration into the unexplained. Thanks for watching.